everyone. We're going to find the area of the region bounded by the given curves y equals 1 divided by x, y equals 1/2 x, y equals x, and also x is positive. So let's do some sketches. Let's look at these two first. So if I graph this, x is positive, so I'm just going to look at my positive axis here. So at 1, there's an intersection. So when x is 1, my y is 1 on both of these. So I'll put a 1 here. So basically the first graph, this one, is something like this, right? And then y equals x is this 45 degrees. I'll put it through there. This is just a sketch, by the way. So there's the intersection point at 1, 1. Now for y equals 1/2 x, that's halfway between here. So it's something like this. So we have another intersection point here. So let's see what that is. If we set these two equal to each other, we're going to get 1. This is your y equals 1 divided by x. This is your y equals 1/2 x. And this one right here is y equals x. All right, so let's see what we got. We're going to set 1 divided by x equals 1/2 x. And that means we're going to have 1 equals 1/2 x squared, or x squared equals 2. So x equals plus or minus square root of 2. However, since x is positive, we're only going to take x as square root of 2. So this happens right here at x is square root of 2. All right. Then we have at 1, it's matching up here. And here we have this part right here. All right. So basically, the area that we want is this area right in here. And if I label this as 0, this is coming out through here. But if I label this as 0, this is A. And this part right here, I'll call this B. This part right here is going to be B. This square root of 2 is called C. And this is called D. Then we're going to do the areas as such that we're going to add the area of this one. So this is going to be 0, A, and B. So that's going all the way down. And then we're going to add the area of A. So it looks like this. We'll go all the way down to B and C, go up to D, and there's this little curve. So this is going to be A, B, and this is D and C. So we're going to add that together. And then we're going to subtract this area that we already added. So we're going to subtract this. What we added was, let's see, this area right in here, because it's included in these two areas. So we're going to subtract the area of this one right here. And that would be 0, D, and C. All right. And then we just use our points here. So basically, if you just take the area of each piece, you're going to get, let's go ahead and do that. For the first triangle is going to be 1/2, and then your length times your width. The second part, that was this piece that looks like that. We're going to take the integral from 1 to square root of 2 of 1 divided by x dx. And then we take subtract the area of the last triangle, which was 1/2, and then the length was square root of 2 times 1 divided by square root of 2. All right, so basically this piece here is just going to be 1/2 plus, when you integrate this, that's going to be log of absolute value of x, and we're evaluating this from 1 to square root of 2, and then minus this piece here. These two cancel out, so minus 1/2. And basically we're just left with this. So that's going to be log of square root of 2 minus log of 1. Log of 1 is 0. So your final answer is just going to be log of square root of 2. Thank you. Have a nice day. Bye-bye.